Hello and welcome again to another of PAVE's weekly virtual discussions. My name is Ed Niedermeyer. I am the Communications Director here at Partners for Automated Vehicle Education. Once again this week we have an extremely important topic. This is arguably one of the most important topics on this because it really highlights the fact that everyone is a stakeholder in autonomous vehicles. And I think that today's topic, which is sort of safe testing on public roads. You know, the public roads are a public space. We all share in them. We all have a stake in them. And when there is experimental technology on those roads, I think it's really important for all of us to understand how that's being done and what is being done to ensure its safety. I do want to note that this is a heated topic at the moment specifically, but I want to be very clear that PAVE is here not to make any kind of judgments about what's right or what's wrong. We're here to share facts and perspectives from people both in the regulatory and in the AV developer world, those different perspectives. And the goal of this conversation, like everything that we do at PAVE, is to make sure that the public has the facts, that you are able to make informed decisions about how we use our public space and more broadly how we relate to this technology as a society. With that in mind, I'd like to introduce our guests. I'm really thrilled to have both of them here today. Really hard to imagine two better people to discuss this fascinating and important topic. First off, from the California Department of Motor Vehicles, we're very proud and lucky to have the Deputy Director, Bernard Soriano. Bernard, welcome.
Hey Ed, thank you for having me. Really appreciate the opportunity to be able to participate on this and look forward to the conversation.
Absolutely, we're so glad to have you here. I'm also joining us from PAVE member Aurora, and by the way, I should mention Bernard is also on PAVE's Public Sector Advisory Council. We have from Aurora, a PAVE member that develops autonomous vehicles. We have Sagar Behere. He is the Director of Systems and Safety Engineering. Sagar, welcome to PAVE and to this conversation.
Thank you so much for having me. Looking forward to some good discussions.
Yeah, so I want to start, like a lot of things with AVs, things are always a little bit complicated by the fact that not only is this technology new, but it introduces challenges that are just totally new, or at least they often seem that way. Although sometimes there are sort of some experiences that we can pull on to understand how best to deal with this. So Bernard, I want to start with you. Are there historical precedents? When we talk about sharing public spaces with experimental technology, going into this challenge, I know California was really active, fairly early on this. Were there historical precedents that you looked to, and if so, what were they? But if not, then sort of like, how did you even begin to think about approaching, ensuring safety on public roads with this kind of technology being developed on it?
That's a very interesting question, because we started working in this space almost 10 years ago when the law was passed that put the onus on the DMV to develop regulations allowing autonomous vehicles on our roadways. And, if you look at history, I imagine it wasn't unlike what happened well over 100 years ago when the horseless carriage was first introduced to society. I mean, back then it was so foreign, and they had these red flag laws that got put into place when these horseless carriages were being operated on the roadways. And they had these items that some of us would view now to be very archaic, things like having to have 3 people in order to operate that vehicle, 2 of them on board, 1 of them walking in front of the vehicle with a red flag, presumably not to scare the horses that would be around. So I think there's some parallels about what happened back then, although I think it's also uncharted waters, because back then what happened was you had a human that was in charge of the horse, and you had a human that was in charge of the vehicle, of the machine. And here we're moving from the human being in charge of the machine to the machine being in charge of the machine. And as a whole, I would venture to say that society is much more forgiving to humans than they are to machines. It was Looking at it from a historical standpoint, it was a very difficult thing to try and move forward, but we did, and we can go into some of the details with regard to our regulations.
Yeah, I'd like to do that. Sagar, I'd like to sort of turn it over to you because, you know, you have to imagine that, you know, if there was an option to just not test on public roads at all, right? Public roads are intrinsically, driving is a risky endeavor. Public roads are intrinsically a dangerous place to some extent, arguably one of the most dangerous places we go on a daily or regular basis. So I'd like, you know, can you help us understand why is it so important that you be able to do that? And then we'd like to get into sort of, you know, how you end up doing that safely.
Absolutely. And, you know, I want to say that we don't start off by driving on public roads. There is a sequence to how things are developed and tested. And typically what we do is we take enormous advantage of advances in simulation technologies. For example, at Aurora, we did well over 2.2 million simulations of an unprotected left turn before we even tried it out for the first time on real roads. So we start by doing a rigorous analysis of the performance that we want, of the safety that we desire to achieve. We do a lot of testing in simulation, and you know, simulation is not an umbrella term. There are different types of simulation which can be leveraged. There is perception simulation, there is motion planning simulation, there are control simulations. So you do a lot of development in simulation, and then you use real world testing as a way to validate your simulations, both for reasons of safety as well as pragmatism. You can do so much more in simulation, and you should do so much more in simulation, and that gives us some sort of guidance on what sort of driving or operation we want to do in the real world. And the data and insights that we gather from safe and limited real world operation in turn guides us on what kind of simulation scenarios to explore. So it becomes a sort of virtuous cycle where you do as much as you can with simulation, and then you vet it out on public roads. So, you know, to get to your question of why public roads, or, you know, why the real world, which is like how I prefer to say it, is that the fact of the matter is, when you have milked simulation for whatever it is worth, at the end of the day, the real world is its own best model. It provides a richness and diversity, which, if judiciously leveraged, can greatly accelerate the deployment and development of this technology. So that is how we go about it. We don't jump onto public roads. We do a lot beforehand, and then use public roads to validate some of the work that we've done.
Yeah, I think that's...
Ed, if you don't mind, I'd like to reiterate what Sagar had just said, because I completely agree that, you know, simulation is a wonderful thing. You can create so many different scenarios, and you can basically do repeatability studies, and, you know, basically run your tests 24/7/52. And so it would be you can do so much with simulation, but simulation by itself cannot be used as the one and only tool. That's not the end all. Real world testing needs to be involved, as Sagar said, to validate what you see in simulation, and then this cycle going back and forth until you get to the point where you're very comfortable with how the technology has advanced.
Yeah, absolutely. And I think we've already sort of identified one of the sort of norms that, you know, has sort of contributed to safety here, which is just don't be on public roads unless you really have to be. So I'd like to actually dig into that, the risk of being on public roads, right? We just mentioned, and we all know that the driving is inherently dangerous, you know, mass plus velocity and lots of people sharing public spaces. Some of this is sort of easy to understand, but Bernard, particularly, I mean, again, when you had to go in and start, you know, really dealing with this challenge and making sure that, you know, California's roads were going to be safe while still allowing this important testing to happen. Sort of, what were some of the risks that you were thinking about, and you know, sort of thought it would be important to address?
Right. So when we were developing the regulations to allow manufacturers to test autonomous vehicles on our roadways, we engaged the industry. We met with all of the different manufacturers, both the traditional OEMs, the tier one suppliers, as well as the startup companies to get an understanding about how their technology has developed, what their strategy is for rolling out the technology, what are some of the pain points, and to a degree, or I would say to each company's credit, they've been very open in sharing information to us and with us, and so we're very fortunate and very lucky to be able to gather that information. That being said, we have to rely very much on the experts, the people that work at the companies, in terms of what they're going to do and how they develop the technology. As it's being tested on the roadways in a real world situation, you know, some of the risks obviously are the risk to the motoring public, the vulnerable road users, but really from a technological standpoint, classifying objects and recognizing objects and doing so incorrectly is something that certainly is there. And that highlights the fact that, you know, this need to have a safety driver or a backup plan in order to ensure that these vehicles are tested and operated in a safe manner really becomes key. Need to have that piece in place should things go wrong, and you're able to gain control and ensure that that people remain safe.
Yeah, absolutely. And I think that's when you think about sort of, you know, brand new technology that's still being developed, you know, it seems like you might not know what exactly could go wrong or when. And that's why that human driver, although as Sagar said, you know, obviously, hopefully you test as much as possible before being on public roads. But then, you know, having that human safety driver seems to be also one of the just things that everyone seems to accept is a really important part of it. So I want to dig into that. Sagar, like, talk to me a little bit about you know, why safety drivers are important, and maybe sort of like we can get into the amount of training and the kinds of training that it takes. You know, are these, you know, temp hires that you're, you know, working part-time? Are these full-time folks? Are they, and sort of what are the training and how core is that to what you do?
That's a great question. I'm happy to share more about that. I will start off by saying that the training and the mission of the safety drivers, it begins long before they even get into the automated vehicle for the first time. You know, at many companies, and you know, this is definitely true at Aurora, we don't use temp drivers. Our safety drivers are full-time employees, and you know, even during the pandemic, we have retained and retrained our safety drivers so that they add value to the company in different sorts of ways. You know, maybe if they're not driving, they can help with labeling. Maybe they can help our simulation teams with assessing scenarios. But you know, what sort of training do these drivers go? You know, the simple answer is they go through a lot of training. But let me double click on that. You know, you of course need the baseline skills to operate and stay in control of the vehicles. But beyond that, you need a first-hand experience of how the vehicle behaves in the presence of faults and failures that could occur. So, you know, at Aurora, this is not something that we do just during the initial corpus of training, but during regular refresher trainings. You know, can you put your drivers on a closed course? Can you inject certain kinds of faults and almost have them develop a muscle memory of what it means to detect that something is going to go wrong, and to resume control, and to viscerally understand how it feels. And it goes beyond that. The drivers, they need to have a very good understanding of how the software works, what is expected to happen on a given mission, and what is the scope of the operational design domain for that mission. So, for example, at Aurora, we have mission pre-briefs that explain all the relevant changes to the drivers so that they are fully prepared, you know, days before they even get into the vehicle for running that mission. And there is a flip side also, right? We have a great deal of respect for the first-hand knowledge that our safety drivers can provide and how they appraise the various dimensions of performance and safety that they are seeing. So we take pains to train them accurately to report vehicle behaviors, via context-specific annotations, even the comfort levels they experience during autonomous driving. So, they are not just drivers. They are, in fact, among the foremost valuable employees that we have, who are helping keep us safe and are helping us advance the pace of technical development.
Yeah,
and to tag on to that's exactly why when we developed the regulations, we had these set of requirements around the safety drivers and about what needs to be in place at various companies with regard to the safety drivers. There are two aspects. One is the need to have the safety drivers, and what about safety drivers need to be in place, that training program that Sagar talked about. Now, it's not for us to dictate what the training program is, because really each company is different. And so we allow the flexibility for each company to develop that training program, but there's at least some modicum of things that need to be in the training program for us to be aware of. Secondly, those safety drivers themselves, as Sagar said, they are key. They're key to this testing program. And so from the standpoint of their ability to drive, we have some things in place that they need to meet individually. They can't be an at-fault driver in a crash. They can't be convicted of a DUI. They can't be have more than 1 point on their driving record. And their driving record is monitored and reported to those companies so that we ensure that those drivers maintain a good driving record throughout this process.
Absolutely.
I would like to, add one more point there. So, hiring the right kind of candidates, giving them extensive and continuous training and refresher courses is important, and that is done. But in addition to that, a lot of engineering resources are also devoted to ensuring that these safety drivers are set up for success, that there is no unreasonable demands placed on them. So this can be at a technical level, like making sure that the vehicle stays within controllability limits. There are multiple ways to disengage autonomous behavior. There are ways to provide the drivers a heads up on what the AV is intending to do, and what sort of situational awareness the AV has. But we also look at human factors to make sure that the drivers are not overloaded, that they do have the ability to remain in control of the situation. And so it's hiring the right candidates, it's training them right, and then it is setting them up for success, which is also equally important.
Yeah, absolutely. And actually, why don't we sort of getting into the actual, so you mentioned screening, you mentioned obviously the training, which seems to be extremely extensive, again, not just driving, but fine muscle skill development, understanding the system that you're working with, all those sorts of things. One of the other things that we hear about a lot from our members when they talk about how they sort of ensure public road safety is just, having certain policies about sort of, making sure, and you sort of alluded to some of those. Sagar, could you just sort of explain on a operational basis, what is it that you do? Do you make sure that there's always 2 people per vehicle? You mentioned sort of limits on time. What are the other sort of operational protocols that you have in place to really make sure that this testing, when you have to do it, is done safely?
Yeah, so as you mentioned that we have multiple drivers. The drivers are trained to be extremely conservative and err on the side of caution. We also have by policy restrictions on how many hours of driving a driver can do. We have policies on topics like, controlled substances and consumption of alcohol, far more stringent than what you would normally find. We have incident response playbooks. We have a whole dispatch and operations team supporting the driver so that they know that, it's not just the driver and their buddy in the car versus everything else out there. They have a lot of support from the home base, so to speak. So those are just some examples. We also train them for particular situations. We give them a lot of heads up on what sort of behavior to expect and not expect, so that they are prepared ahead of time for what to expect.
Yeah, and it seems like a lot of what you're describing is partially policies, but also a lot of it is just inculcating the right culture, which is something that kind of seems to be a theme going through this. And I want to get into that, but first, Bernard, sort of, you know, one of the really interesting things I think it's probably really important for people to understand is that, you know, safety in this space, it really does depend on a balance between regulation and then sort of the internal cultures and norms that these companies, you know, around safety and doing the safe thing. Just and maybe if you could just explain a little bit sort of what the regulations are in place, like when a company wants to start publicly testing an AV, and sort of if you could do that in a way that illustrates sort of the you know, what you've decided you need to regulate versus sort of how, you know, where you want to let these companies sort of allow their cultures to really sort of do the heavy lifting on safety.
Yeah, absolutely. You know, we had to really balance what our responsibility is from a state perspective versus the federal perspective. You know, the feds are responsible for the safety of the occupant of the vehicle, and they do that through the federal motor vehicle safety standards, seat belts, airbags, brakes, things of that nature. States, on the other hand, are responsible for the safe operation of the vehicle. We do that by licensing people to drive, and, you know, people show a modicum of skill to be able to operate that vehicle. With automated vehicles, there's that blurring of the lines, and we really had to leverage what's in place now. And I'm speaking to this self-certification model that all manufacturers subscribe to here in the United States, where they self-certify that they meet the federal motor vehicle safety standards for their vehicles. Using that model and that mantra is how we move forward with the regulation. So manufacturers need to certify that they've tested their vehicles in a way that is safe, and we put in place some of the more tactical things that they need to meet. I mentioned the safety drivers, but during the course of testing, they need to report to us certain things, the crashes that occur, and then an annual report on what we're calling those disengagements, whenever the technology has failed and the safety driver needs to take over, or the safety driver felt like they need to take over themselves. There needs to be an accounting of that and reporting that to us on an annual basis. So we've got those types of things in place. In addition, when companies are moving from testing with a safety driver to testing without a safety driver, taking that safety driver out, we're requiring the manufacturers to develop a law enforcement interaction plan. And that plan is a how-to guide for law enforcement and first responders for them to use and be aware of on how to interact with that vehicle should the need arise. Those kinds of things and more are in place because we felt we needed to have some things that would assure us that the companies are responsible in moving forward with the technology and are at a point where they can safely take this on the roadways.
Yeah. And so that, you know, so clearly, you know, a lot of safety really is on the shoulders of companies like Aurora, the companies who are doing the public road testing, and it's really about, the norms and that these companies are going to, not just do the right thing, but really cultivate trust. Why is that trust so important? Why can people count on that? To keep them safe, which, and again, it's a balance, right? As Bernard was saying, there's absolutely certainly in California, there's some regulation, but other states, depend much more on that, companies doing the right thing. So if you could just talk about why trust is so important and sort of how that relates to your culture and in everything that you do at Aurora.
Yeah. So, it almost sounds like a rhetorical question on why trust is so important, but I do want to double click on that and elaborate on it a little bit. So, the technology that we are developing, we are doing it to improve safety on our roads and to save the thousands of lives that are lost every year in traffic incidents. And so, if you are creating a technology to add safety and to improve upon the state of affairs, it is incredibly important for people to trust that technology. And this technology, as we've been discussing, some of its development happens in the real world on public roads. And so people have a right to know, and it is our responsibility as AV developers to educate them on not just the benefits of the technology, but be transparent about how we are developing it, why it is going to be safe, what sort of safety culture they should expect from companies, and what are all the rigorous safety procedures that are put in place to ensure that this technology is developed safely. The other part is, this is a bit unprecedented in the sense that the technology development is under a microscope like no other. When an aircraft company develops an aircraft, its development and testing doesn't necessarily happen out in the broad public view, which is not the case with self-driving cars. So given our mission of improving safety, given our mission of serving people, given that we are developing some limited aspects of this technology in close proximity with members of the public, and this is happening under wide public view, it is surely important that we explain why people need to trust us. We need to build confidence, because if that trust is lost, then what are really we working for here?
Yeah, absolutely. And Bernard, I want to get your perspective on this as well, because it is relevant, right? If you can't regulate everything and you need to count on this, and I guess I'd be curious in, whether you think the industry in general, the situation that we have right now, do you feel that it is going well?
Yeah, absolutely. I think that, to echo what Sagar is saying, this issue of trust is very much a shared responsibility. I believe it's shared with industry as well as with regulators. We really need to be able to be as transparent as possible about the technology, and as well as how this technology is going to be rolled out. I've always said that communication in this is paramount. We really need to communicate how the technology is progressing, and to assure the public that the technology is working before it can be put out for public consumption. The issue of ensuring that this trust is withheld is key, because in the end we need to have public acceptance, and that public acceptance is only going to come about as the public sees the technology working, and working in a way that would benefit us, and that overall theme is keeping us safer, safer than what we experience now on the roadways.
Yeah, and I think that this trust issue, it becomes, for me anyway, it was something I heard everyone talk about, and I kind of got it, but I think I didn't really understand it until I actually rode in a fully driverless vehicle. And there's something about that where you're just like, okay, yeah, trust is really important in this business. And we've had a number of questions from the audience and folks when they registered about sort of what happens in this whole world when you do make that step to driverless. Now, I know, Sagar, I don't want to put you on the spot too much, because I know that Aurora has not applied for permits or announced any plans about moving to driverless. But if you could just sort of help us understand, and Bernard, I want to get your perspective on this as well. But let's start with Sagar. Sort of, how should people be thinking about that step from having that safety driver, which, as we've heard, is so important to ensuring safety during the testing, to then going to having these vehicles operating fully driverlessly?
Yeah, let me start off by saying that at Aurora, we are on this mission to deliver the benefits of self-driving safely, quickly, and broadly. There is a reason why safely comes first. And, in very explicit terms, our goal is to pull the safety driver. We are creating technology for driverless operation. So, how do you go about assessing when it is time? And one of the ways to do this is to create a very, very rigorous framework. The common term for this is to create a very comprehensive safety case that goes into an extraordinarily high level of detail on what are all the aspects that need to be considered, what is all the argumentation that needs to be built, what are all the claims that need to be made, and what is the supporting evidence that all of those claims are getting fulfilled. So when you create a very comprehensive safety case and you are able to tie each item of that safety case to concrete evidence, to concrete argumentation, and you are able to, gradually work through every leaf, every node of that safety case, and in a very transparent manner say, we claim X, here's why we claim X, here's the evidence, and you do that on a continuous basis, right? Safety is not a box that you reach once and then you move on to other things. You need to remain established in a state of safety. You need to continuously show that all items of your safety case are, as a matter of process and as a matter of culture, getting the attention they need on a continuous and ongoing basis. And you moreover have mechanisms to know that when certain indicators are trending in a direction that you don't want, that you can step in and correct them well in advance of time. So when you have created such a rigorous framework by pulling in state-of-the-art studies, by pulling in a lot of experienced experts, that is when you can start thinking of pulling the driver. When you think of how much verification and validation is sufficient, and if you're able to credibly argue that the system that you've built is in fact going to improve by several factors the state of safety as it exists today. So that's kind of the overall framework. A lot of people expect this technology to be absolutely perfect. I think it's been said in the past that safety delayed is also safety denied. And so it's a delicate balance that we need to walk, but absolutely safety needs to come first. And you need to be able to convince yourself as a company and all your stakeholders on why you are safe. And if you are not able to do that, then basically you're not ready.
Yeah,
and
I think that's
I'd also add that, I think it's really incumbent upon industry as well as government to really set realistic expectations of this technology. Sagar sort of alluded to it, where when the public hears about self-driving vehicles or automated vehicles, it's natural for them to automatically think of the level 5 vehicle, and when really we're just at the infancy of moving towards level 3 and then eventually level 4. But so setting expectations, I think, is key, and then also leveraging what others are doing. So at the federal level, this voluntary safety self-assessment report that some companies are providing, that is a good piece of information that should be communicated to the public. And so when we developed our regulations to allow testing without a driver on board, we were looking at those things. And that's why we said if a company has filed a voluntary safety self-assessment report, they need to provide that to us, or at least provide it so that the public would be able to see it. And NHTSA does that as well. So, things of that nature where we work collaboratively with the feds as well as with the industry, I think works. And I think that's the one way that we can really work together to try and get this technology in a place where it will really, where society would really reap the benefits.
Yeah, and I think right there you see sort of how this is really this cooperation between regulation where it's needed, but then also relying on companies to assess themselves in an honest, credible way, which I think gets back to Sagar's point of why safety culture is just so important in this business. Bernard, could you also just maybe explain sort of what other requirements coming in the state of California when you want to go to driverless? I know you have separate permits. You develop the driverless permits sort of later in the process. What does that step entail besides the VSSA point that you just mentioned?
Right. So with regard to the deployment, much of this is a self-certification model, again, where the companies need to certify that they have adequately tested the vehicle, and the technology, and feel they are ready to move forward with deployment. We're not in a position to speak to each one of the different technologies and lay down various requirements. because really the experts are like Sagar and the other companies that are developing this. We really have to leverage their knowledge and their ability to be able to safely test the technology and get it developed to the point before it is ready for deployment.
Yeah, and Sagar, if our Twitter mentions are anything to go by, there seems to be some people who just really don't believe that this technology can be tested on public roads safely at all. And I think you sort of alluded to the fact that there's some intrinsic risk no matter what, which is why you try and limit it as much as possible. But I guess what would you say to someone who just did not seem like they wanted to be convinced? What is the most compelling sort of argument for the safety and for what's allowed it to be done safely so far?
I would basically say that the instinct to distrust a new technology that you don't yet know a lot about is an understandable one. And so, I wouldn't directly dismiss any such fears, but I would like to entertain them, double click on them, and explain things. Now, this might sound a bit patronizing when I say, you're distrusting something you don't understand, but it really is not. On a tangent, there still exist people who have a fear of flying because they believe it cannot possibly be safe, or because they are not in control when the airplane is taking off. And so the way I say it is our responsibility as developers of safe self-driving technology to educate others on what we are doing and the safety impact of the technology. When we lay out a series of arguments for why we are testing safely, and why we are developing this technology safely, by definition, it means that we are doing it with an absence of unreasonable risk. Risk in life is an ever-present thing. What safety says is you should eliminate the unreasonable risks. And so I remain optimistic that by engaging in proactive transparency and together with rational dialogues and critical thinking, we will be able to convince reasonable people that this technology can be developed safely and that we should go a step forward and insist on harvesting its benefits for society.
Yeah, I think you brought up a bunch of really important points, but Bernard, I want to get your view on this too, because if something bad does happen in the state of California anyway, I mean, people are going to be looking at you. So clearly you have some confidence that the system that we have is working, can work. Where does that confidence come from?
Yeah, I would say to the folks that, tell you that no one should be testing on the public roads because it's unsafe. I certainly don't want to dismiss their feelings, and we need to acknowledge that they feel that, but at the same time, I think it's important to really point out about how unsafe it is right now on those roadways. I mean, the number of people that are dying on our roadways every year is staggering. I mean, and we've been on this for half an hour, and unfortunately, in that 30 minutes, 2 people have passed away on our roadways, 1 every 15 minutes approximately. And really, this technology can only help reduce that number. And so it really behooves us to do as much as possible to ensure that technology is to the point where it can be deployed. Because really, as a society, we can't continue on like this by having our roadways be unsafe for our road users. So it's that's kind of the theme that I would carry forward, because we really need to improve our transportation system.
Absolutely. Well, I think that's a really good place to leave it for now. I think that you've both raised just so many fascinating issues, and I agree with both of you that educating the public about this stuff is so important, so that people really understand it. Because certainly the data shows us that a lot of the fear of autonomous vehicles specifically does come from people who don't know really much of anything about it, and I think the first step in that is to start to understand a little bit more. And I think that this conversation was a great step in that direction. I think there's a lot more here that we can talk to, and I hope you all both will come back so that we can continue to explore these issues and make sure the public has what they need to really understand this and make good decisions about it. So Bernard Soriano, California Department of Motor Vehicle, Deputy Director. Thank you so much for being here.
Thank you for having me. Really enjoyed it.
And Sagar Behere from Aurora, thank you so much for taking the time to be here and share your expertise with us.
Thanks for having me. It was a pleasure.
And thank you to our audience for taking the time to educate yourselves about this. As we said, you know, sharing your public road with experimental technology is a big thing, and it's important. And I hope that this conversation has helped you understand more. You know, we are the VSSA's voluntary safety self-assessments were mentioned in this. Our Twitter account is actually currently going through every day and posting another one. If you'd like to get a sense of what that is, I think those are some of the most important documents in this whole space, because as Sagar said, you know, this is how companies are proving to themselves and to the public that this is safe. So I think in particular, if you do have concerns about this, reading those, you can go twitter.com/PAVE campaign, and you'll see those, and you get links to those. And yeah, and so thank you for taking the time to educate yourself about autonomous vehicles, and we hope you will join us again for future virtual discussions here at PAVE.